They said habitation ends where the oxygen thins, but they were wrong. High above the troposphere, sitting silent on a bed of white vapor, lies the impossible. This is not magic, nor is it anti-gravity. It is the single heaviest structure ever raised by human hands, defying the earth below it. A metropolis of 3 million souls, suspended at 30,000 feet. A cathedral of steel and pressurized glass strictly forbidden by nature. To the naked eye, it appears to float. But physics demands a price for this elevation, and the cost is calculated in trillions of tons of tension. Welcome to the Ether Vein platform, the only city on Earth that never sees the rain because it exists eternally above it. Building here presents 3 fatal problems. First, the wind shear at this altitude can strip standard steel plating like paper. Second, the foundation. There is no ground here, so we are building on the most unstable element in existence, the air itself. And third, the cold. At -50 degrees, standard structural welds become brittle and shatter under load, requiring a new metallurgy. If you appreciate engineering that pushes beyond the impossible, make sure to subscribe, because we are decoding the blueprints of the future. The solution began not in the sky, but deep underground. The foundation isn't a slab, it is a tension network anchored into the crust. We visualize the load distribution here. The city doesn't push down, it pulls up, acting as a suspension bridge where the sky is the river. But to hold a city steady against a jet stream, you cannot use rigid columns. You need a spine that breathes. Enter the Titan-class piercers, 12 massive needle-like towers rising 10 kilometers from the planet's surface. These are not buildings. They are the nails of the world, constructed of carbon-reinforced concrete to pierce the cloud layer. At the pinnacle of each piercer sits the primary clutch, a mechanical gripping system the size of a stadium. Watch the scale of these gears. Each tooth is the size of a truck, designed to expand and contract with the thermal shifts. The materials arrived via heavy-lift dirigibles, the largest airships ever built, carrying payload modules up the vertical drafts. We see the docking procedure. Precision is measured in millimeters, despite the crosswinds howling at 200 kilometers per hour. The primary clutch engages. Massive hydraulic rams drive steel locking pins into place, securing the foundation ring. This ring is the spine. It connects the 12 towers, creating a web of tension cables thick as highway tunnels. The cables are spun from graphene-infused spider silk composites, lightweight yet capable of holding the weight of a mountain. With the web verified, the mega machines begin the true work as the crawler cranes emerge from the tower shafts. Phase 1 of habitation is the floor plate. It is not solid concrete, but a honeycomb lattice of aerospace aluminum. Robotic assemblers weave the floor sections together, and sparks fly into the stratosphere as the lattice takes shape. We look at the cross-section. The floor is 80% hollow, filled with helium pockets to reduce the dead load on the cables. The first residential modules are lifted, prefabricated pressure vessels, sealed against the thin atmosphere. They slot into the honeycomb floor like cartridges, creating plug-and-play infrastructure at 30,000 feet. Connecting the utilities is the next challenge. Water must be pumped up 10 kilometers, and the pressure requirements are staggering. High-pressure cryogenic pumps push fluids up the tower cores, and the friction heat alone keeps the water from freezing. The power grid comes online. Nuclear microreactors installed in the counterweights provide the gigawatts needed for life support. As the city spreads outward from the towers, the balance shifts and the center of gravity must remain perfectly aligned. Computer-controlled gyroscopes, massive flywheels spinning in vacuums, counteract the shifting weight of construction. We are now at 40% completion. The industrial districts are established, and smelters and refineries begin processing atmospheric carbon. The air scrubbers activate. Massive intakes suck in the thin air, compressing it to breathable density for the workers. Visualizing the airflow, the city breathes like a lung. Intake, compression, circulation, exhaust, a closed-loop ecosystem. The agricultural domes are installed. UV-shielded glass protects the crops from the harsh solar radiation at this altitude. Hydroponic racks stretch for miles. The city grows its own food, independent of the surface world below. Transport tubes connect the spires. Maglev trains running inside vacuum tunnels, silent and frictionless. The transit map looks like a neural network, efficient, redundant, and designed to evacuate the entire population in minutes. Construction reaches the outer rim. This is the danger zone, where the leverage on the central cables is at its maximum. Cantilevered promenades are extended over the abyss, nothing but glass and steel between the pedestrians and the clouds. The tension sensors glow amber. The load is heavy, but within tolerance, and the engineers hold their breath. Bolting the rim requires the skyjacks, humanoid riggers in pressurized suits, welding the final seams manually. It is a ballet of sparks and void. One mistake here means a fall that lasts for 3 minutes. With the rim secured, the atmospheric shield is deployed, an electromagnetic field to deflect high-altitude radiation. The schematic shows the field generation, a dome of energy invisible to the eye, but vital for cellular health. Interior finishing begins. Parks, plazas, silence. The howling wind outside is silenced by triple-layered aerogel insulation. The city is now a living organism, but nature has one final test: the stratospheric shear. Alerts flash across the control grid. A thermal inversion creates a sudden, violent updraft beneath the platform. The wind speed jumps to 300 kilometers per hour, and the entire city begins to oscillate. We see the stress map. Red zones flare along the primary connector cables, and the structure is twisting. Inside the towers, the dampeners are bottoming out. The hydraulic fluid boils from the pressure changes. The oscillation frequency matches the structural resonance. This is the bridge killer, the wobble that tears steel apart. Emergency protocols engage. The active mass dampers, massive pendulums inside the spires, are released. The pendulums swing in opposition to the wind, counteracting the force, fighting physics with physics. Slowly, the red zones turn green. The vibration subsides, and the grip of the towers holds firm. The engineering holds. The shear passes, and the city settles back into its silent hover. Routine maintenance drones deploy to inspect the stress points. Microfractures are sealed instantly with laser sintering. The sun begins to set. At this altitude, the sunset lasts for hours, bathing the metal in gold. Lights flicker on across the platform, a constellation of human presence against the darkening indigo sky. What was once impossible is now a home, a testament to the audacity of industrial ambition. We have not just conquered the land, we have colonized the sky.